So let's look at a few of the different criteria and talk about them, and I'll talk about my favorite one too. The first is just the lack of falsifiability. Pseudoscience is things that act like it's falsifiable, but it's not. Popper's example, he differentiated between Freud and Einstein. Basically, what he said is Einstein's view was risky. It was falsifiable. He made claims that could be wrong, and then basically showed that they were not falsified by some experiments. And then he basically argued Freud's theory of psychoanalysis it could be used to explain pretty much anything. It wasn't risky in the sense that it didn't have any criterion for demarcating whether or not it was true or not, and it could only be used to confirm beliefs and never actually test whether it was true or false. So the lack of falsifiability basically means, is the theory risky? And I think that there's something very, very intuitive and something that should make us go, yeah, if somebody is just inventing explanations or what we call just so stories for something, as opposed to actually having the virtue of maybe humility or open-mindedness of saying, here's my theory and I could be wrong, and here's what would prove me wrong, and here's what would prove me right. There's some idea of that sort of being or having some issue. And that's, I think, if people aren't doing that, it's maybe more likely that they're doing pseudoscience, at least according to Popper's definition. And I think this is still probably the most common use of the term pseudoscience is lack of falsifiability. And Popper at the time actually also went off after natural selection. This was pretty controversial. And he later recanted because he's like, look, they pointed out to Popper, hey, look, like natural selection can't be falsified because it presents this tautology, blah, blah, blah. And I think, people use this to say like, oh, look, Popper's saying natural selection is an actual science. And then I think he saw some of the experiments that people were doing, specifically with fruit flies and these sorts of things. And he later kind of recanted and revised his view and just said, it's very difficult to test, but it's not necessarily impossible. And he allowed it to be under the moniker of science. And he influenced what we call scientific skepticism as well, right? Not holding a positive belief until attempts to falsify it have failed. This goes back into what we talked about last time in terms of the demarcation problem. A good scientific theory, according to Popper, and according to, I think, most people and most scientists, are ones that can withstand repeated attempts to falsify, and we can be more confident in the things that we have tested and have withstood challenges and tests. And with that too, inductive claims hard to prove, pretty much impossible to prove in the sense that, all swans are white is an inductive claim. But if you do a lot of tests, maybe you can be more confident in a conclusion that is provisional, put it that way. Criterion 2 says a lack of testable predictions. This is an interesting one because it's very, very similar to Popper's criterion, but this one is, I think, particularly used in many cases to exclude intelligent design, that it has to make predictions that are testable or repeatable, maybe in a certain way, to be considered science. And the first thing we need to ask is why restrict science to this? If the goal of saying this is just to say, well, the goal is so we don't include intelligent design, then intelligent design can just say, okay, well, maybe we're not science, but we're doing actual philosophy, or we're actually studying what reality is, and this testable predictions thing has its own epistemic limits, and maybe that would be a place they could go. But regardless, let's look at this because I think it also does tie into Popper's idea that when we do scientific experiments, we're not just always doing them to find out what is true. Sometimes we want to find theories that are useful, or in the case of engineering, can be used to make predictions about the future, or that can be used to build stuff that helps people. This is why science and engineering get a lot of funding. So saying that science has to have testable predictions can be done in a way to kind of direct fundings into areas that are more likely to, in some way improve the human condition. So I'm not just saying it's done with this agenda to exclude intelligent design as much as done maybe for a pragmatic or other sorts of reasons. And this differentiates from Popper's criteria, in which there can be theories that are in principle falsifiable, but they're not falsifiable in practice. They make these claims that are difficult. The problem with this definition, and maybe it's not a problem, but the thing that I think makes people uneasy about this is people like Stephen Jay Gould made the difference between, historical sciences, which investigate the past, and then operational sciences like physics and chemistry that find generalizations of things that are currently existing. And this would make things like cosmology, origin of life research, evolutionary psychology, all of these theories pretty much pseudoscience, at least until they can make testable predictions that can be falsified, or maybe until they make enough testable predictions to meet some like minimum threshold. Because I think there are cases when, for instance, evolutionary psychology has made testable predictions. There's one that comes to mind about depth perception. It's like, okay, people are much better at viewing depth up and down versus left and right because you're more likely to fall. This is a natural selection type argument, and people made this prediction and then were able to actually test that, yeah, this is true. But it's very clear that many of the theories in some fields are much more speculative than others, and where you draw that line about what is testable and what's not can be very difficult. So for instance, let's just take origin of life research for a moment. We can make testable predictions about certain reactions or how life could have arisen given experimental data. I don't think this is controversial at all. But claiming that this is life, how life actually came about, is not a testable claim and would thus be pseudoscience. Even if the evidence was like so overwhelming that this is the best argument explanation we have, all of the other ones have all of these problems, we can be pretty confident in this, you would still not be able to say this is science because you can't repeat the actual experiment or the sort of historical piece. Claiming this is how something happened in the past that we will never have access to would thus be a pseudoscientific claim. And I think that's one of the reasons why this definition is controversial, because it does leave out so many things, or it sort of provisionalizes many fields that are currently considered science now by the public and kind of says, no, you guys aren't really doing science, or you're doing like semi-science. Yeah, I would say, yeah, and then this would obviously rule out something probably like intelligent design, although perhaps maybe they could make a testable prediction like, hey, people are going to have a lot of trouble doing this and this because we believe this required an intelligent designer. But it wouldn't necessarily rule out other things like cult research or ghosts, because in theory those could, not just in principle, but in practice, one could make testable predictions based on these.